Good morning, everybody. Welcome to Homework Helper for 3.3. We lost them before our quiz. Let's go ahead and get things started. The first thing that's talking about is a lot of exponent rules, and so we'll go ahead and go over that. I'm going to leave off standard form as I do this, but I am going to go between exponential and factored form to make sure that we understand this. So when I look at this, we've got 1, 2, 3, 4, 5, 6, 7 sevens. So that's 7 to the 7th power. 2 to the 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There you go. This is 81. Ooh, so that's actually kind of tricky. 81 it gives us. So how do we work backwards from 81? Well, we kind of have to think about what are the factors of 81. So let's look at 81, and I know that that's 9 times 9. So that could be 9 times 9 or 9 squared. But you know what? 9 can even factor further, because 9 is just 3 and 3. So actually what we have is we have 3 to the 4th. So this is 3 times 3 times 3 times 3, or 3 to the 4th. 11 to the 5th is 1, 11, 2, 11, 3 11s, 4 11s, 5 11s. 5 11s. Sweet. And so on and so forth. Here, it's asking us to do it in multiple equivalent forms. So while yes, we can do things like 2 times 2 times 2 times 2, let's use some of these exponent rules so that we can do it a little bit different. So that 2 to the 10th is the same as like 2 to the 5th times 2 to the 5th. Or it's also 2 to the 5th squared, because 5 times 2 would be 10. Okay, like 3 to the 7th, well that would be the same as, 3 to the 8th times 3 to the negative 1, right? That would give us 7. It would also be the same as, 3 to the 4th times 3 to the 3rd, etc., etc. Ooh, 13 to the negative 8. Well, that would be the same as 1 over 13 squared to the 4th, because that would be 8, and the negative would make us not divide it, etc., etc. So just kind of play with these numbers a little bit based on the rules that we already know. Next, we have to figure out if these are all equivalent. If these are all equivalent. And justify why or why not. These first ones are actually kind of challenging because we have an x to the minus 1 as our power. And we know that when we have this happening, when we have an exponent happening here, we know before the way that we've seen it has been like we would have 3 to squared times 3 to the 4th, and that's the same thing as 3 squared plus 4. So when we look at this 3x minus 1, we have to kind of think about that and rewrite that as, we're still going to have that 5 on the outside, but that's the same as 3 to the x over 3 to the first, right? Because x minus 1. Okay? And so if that's happening, and this is 5 over 1, this is really going to be 5/3 times 3 to the x, because this will become our fraction, this will become our other fraction. So what we're trying to see is if these are going to be 5/3 3 to the x. So let's see if that actually happens. So with 15 here, this is going to be 15, and it's going to be 3 to the x over 3 squared, which gives us 15 over 3 squared times 3 to the x. That's 15 over 9 times 3 to the x, and those can both reduce by 3, giving us 5/3 times 3 to the x, and that's what we have. And see, this one it says 3/5 3 to the x. So we know this one's wrong because we have 5/3 for both of our others. So we will say that these are not equivalent, and we have justified why. Let's go ahead and do the same thing here. So 64 times 2 to the negative x. Well, this just means we're dividing it. So that's just going to be 64 over 2 to the x. And that's it. That's all we can do. 64 2 to the x. All right, we got there. What about this one? This is 1/2 to the x power. 1/2 to the x power. Well, this is going to be the same thing too, because remember, like if we had 1/2 to the x, well 1/2 we can also write as 2 to the negative 1, right? Whoops, and this is x. So negative 1 times x, that would be 2 to the negative x, which is exactly what we had here. So when we raise this to the x power, okay, this is the same as 64 times 1 to the x over 2 to the x. But think about 1 to the x. 1 to any power is still going to be 1, because 1 times itself infinitely is 1. So this ends up just being 64 over 2 to the x. So these are all the same. These are pretty complicated, but we got to be able to factor out these rules, play with them, and really see where they take us. Let's look at this one here. See, this one doesn't have an exponent. This is just what happens. This is just PEMDAS here. So we factor in, or I'm sorry, we distribute that 3 to get 3x minus 3 plus 4, which is 3x plus 1, which this is 3x minus 1, so that doesn't match. And then this is 3x minus 6 plus 7, which is 3x plus 1. So these two match, but this one doesn't. And that's it. Let's go to the next one, where it's asking us to simplify into exponential form. So 7 to the third, 7 to the fifth, 7 to the second. That's going to be 7 to the 3 plus 5 plus 2, which is 7/10 to the 10th power. Here we have 4 being raised to the 5th power. That means we multiply, so this is 3 to the 20th. Let's just jump to another problem. Here we have y to the a over y to the b. Look at this. Look at this crazy thing. So that's going to be y to the a minus b, right? Whenever we divide, we're just subtracting. And let's look at this one. Y to the ac all over y to the b. So these multiply first, because we do exponents before division. So that's y to the ac power divided by y to the b power. So now we subtract that, so it's y to the ac minus b. Just following those rules. All right, guys. That'll do it, and I look forward to the quiz tomorrow.